So let's revisit what we have discussed in the last class. In the last class, we have discussed about 2D viewing. In the 2D viewing, we have seen what is window, what is viewport. A window is a selected area in world coordinate for display. Means what is to be display, and viewport, as you can define the area on display device in which window image is to be display, means where is to be display. These are the two important terminology we used for 2D viewing, 2D viewing pipelining. Okay, so we have discussed there is a word coordinate system. In this word coordinate system, we have selected a particular area, means what is to be displayed, and after selecting this particular area from the viewport, we transform this selected area into our display device. We call this display device, display area is called viewport. And what we have what the area we have selected, we just translate or transform into a device coordinate. It's called device coordinate, and this device coordinate where is to be displayed we find. For finding these points into our display device, we have seen a formula. This formula to find the points into our device coordinate from a window. Okay, so this terminology you are familiar. XW mean, which is the left boundary for your window, and which is the right boundary for the window, where XW is maximum and YW minimum is the bottom boundary of your window, and YW maximum is the top boundary of your window. And the same is same for the view port or device coordinate. XW min is the left boundary of your device coordinate or viewport, and it is the right boundary, where XW maximum is the right boundary of your viewport, and YW min is the bottom boundary of your viewport, and YV max is the top boundary of your viewport. These are the coordinates for your window and viewport, and this is the formula from which we can find the points into viewport from a window. All we have discussed, so there is no need to discuss anymore. And the clip operations means after selecting the area, this using a window, the remaining area which is outside from your window, we need to clip. Means we do not want to consider those portion which is outside, means we need to some kind of clipping. Clipping is a procedure in that we identifies those portion of a picture that are either inside or outside. Means we're just finding the area of picture which is inside or outside. If it is outside, we just clip. If it is inside, we just consider for display. In the clip operation we have seen, so what there's a many kind of clip operations. First is point clipping. We just find the point clipping. In this point clipping, we eliminate those points which are outside the clip window. We have a clip window and we determine the position of your point. If it is outside, we clipped, or if it is inside, we draw or we consider for display. And if your clip window is rectangular, then these are the coordinates for your clip window, and according to this we determine. And these are the 4 inequalities condition we check for point. It is inside or outside from your clip window. Just consider this is your clip window. Just consider this is your clip window, and this is your XW min, XW max. So what we check, the point's position. Suppose this is the point and the coordinates of point are XY. So we check this X value. First we check the value of X should be greater than this left boundary. Okay. Then we check this value of X should be less than this right boundary. Then we check the value of Y. It should be greater than this your bottom boundary, and it should be less than from the top boundary. If all these 4 condition is satisfied, then only this point should be considered for display, otherwise it will be discarded. Okay, so always we will check these four condition, inequalities condition, for considering a point. And the next is line clipping. We check condition for line. It is inside. There are several condition. Again, we have a clip window. Again, we have a clip window, and we have different lines. Okay, line, this line, this line, this line, that line. Okay, so what we check if it is completely outside from your clip window. This is your rectangular is a clip window. If it is completely outside, we will reject. Okay, as you can see, this line is completely outside, so we can reject this line. And if your line is completely inside, we will accept that line as it is. Okay, if some portion of your line is inside and some portion of your line is outside, we need to clip. Means in this case, we need to clip. We need to clipping required. And this, as you can see in this line, there is some portion is outside, some portion is inside, and again some portion is outside. So again we need to clip this line from these two boundaries. Okay, as in this case this line is completely outside, so we will reject it. So how we can determine the these cases, it is inside, outside, or need to be clipped? Okay, all these operations we perform in line clipping operation. So for line clipping, we have first we have discussed Cohen-Sutherland line clipping. If you remember, we have discussed our first line clipping algorithms, Cohen-Sutherland. In this Cohen-Sutherland clipping algorithms, we have given this region code to each point of line, in which region your line point is lying. Okay, so according to this, we have given this is your clip window. This, okay, and corresponding to this your clip window, we have different region. As you can see, there is a 3, 3, 6, and 3, 9 region. One which is inside is given the code 0, 0. If you remember, we have given the code ABRL. If your point is above from your clip window, from this line, if your point is above from this point, it is above, so we'll give the first digit, or the 4-bit digit, the first bit is set as 1 if it is above. And if your point is below your clip window, from this line, below from this line, then we set the second bit as a 1. Okay, and if your point is right side from your clip window, this is the boundary, right side boundary, and if your point is lie in this region, the set third bit as a 1. In the same way, if your point is left side from your clip window, this is your left side boundary, and if point is in this area, the set the last bit as a 1. Okay, so as in this form of AVRL, we have given the region code. Okay, these are the region code. If it is below your region code, above your below your region code, below sorry, not above your region code, sorry, not above this boundary, not below this boundary, not right side in this boundary, not left side in this boundaries, and all the bits are 0. No, not any none of the condition is true, so all these bit are 0, means it is your inside your clip window. Okay, so after this we find the position of your line endpoints. Okay, so there is an endpoints. Suppose this is line, it has 2 endpoints, so find the each endpoints region code, in which region your point is lying, and according to this we perform some condition, we apply the AND operation. Okay, this region code, so just consider this line and region code of both the end points are 1 0 0 0 and 0 0. If both the numbers are non-zero and apply the AND operation, if you get 0 0 0 0 means there need to be clip. If the AND operation of this region code is again a non-zero number, means some kind of this number. Suppose you apply the AND of these two, you will get 1 1 0 0 0 means non-zero number, means it is completely absent. You can reject this line. Okay, so these are conditions we will check in Cohen-Sutherland for clipping. All these conditions we have discussed in the last class, so I'm not taking much more time in this Cohen-Sutherland. Okay, till this point, if you have, if do you have any doubt, you can ask. Or till the last class, if do you have any doubt, you can ask me. So let's move to today's class. Do you have any doubt? Okay.
सर
Yes, please.
सर वो आपने इंटरसेक्ट पॉइंट कैसे निकाला? मतलब आपने उसमें जो उसकी कोड लिया था 0 0, तो वो कैसे जब अपन क्लिपिंग करते हैं तब?
देखिए, first we will apply the AND operation, and based on condition, if there is a need to be clip. Suppose this end 2 points, these are the two end points, and after applying the AND operation on this region code, you get the 0, means there need to be clip. If it is required the clip, we find the intersect points from that boundaries. If there is a line, your line, and this is your boundary, to find the intersect point, you have two lines. The equation you have given this equation of line and equation of this line, this boundary is x w min, so easily you can find this intersect point. In the same way, you have given the equation of this line and this line, top boundary. You can find this intersect point, and at this intersect point, you just clip. In the what portion which is above, just clip. In the what portion is left side, you just clip. And the remaining point, the remaining line is just considered for display. Now is it clear?
यस सर.
Okay. We have also seen some example of on Cohen-Sutherland in last class, if you remember.
यस सर.
Okay. So, any the other students have any doubt? So let's move. So in today's class, we are going to discuss a next line clipping algorithm. The next line clipping algorithm is Liang Barsky line clipping algorithms. Liang Barsky line clipping algorithms. So the Liang Barsky is a line clipping algorithm. This algorithm is more efficient than Cohen-Sutherland. Efficient in terms of time and complexity, and can execute even for three-dimensional clipping. This Liang Barsky algorithm we can also extend to three-dimensional clipping as well. So what are the key points about this Liang Barsky are? First, this is the faster, because it's take less time, and it has less complexity compared to Cohen-Sutherland. This is faster compared to Cohen-Sutherland. Okay, this algorithm is considered to faster, and it's used the parametric line clipping algorithm. So the first is its use parametric equation of line. The first point is it's use the parametric equation of line, and the second is the inequalities describe the range of clipping window, which is used to determine the intersection between the line and clip window. So see the whole algorithm. Liang Barsky line clipping. Liang Barsky line clipping algorithm, it used parametric equation of line. Anybody know the parametric equation of line? If you know, you can write in chat, or you can even speak. Parametric equation of line is x equals to x1 plus t into x2 minus x1. If you given the endpoints x of line, so the parametric equation of line you can write as this. So how you can find this equation? I just explain. Just see, this is your line. The endpoints are x1, y1, which are given x2, y2. To find the parametric equation of line, just consider at particular point x, in intermediate point x and y. Okay, so how you can find the value of x, y, which is intermediate intermediate between these two endpoints of line. To this, just consider at the time 0 means initially your time 0 you have at this point. At the end, when your time is 1, means the unit t is just considered a time. At the time 0 you are at the initial point. At the time of 1 means it's a unit. Okay, you are reached to the end point. So at somewhere at this point is considered as a t. What is the way? This point is t. So you have traveled from this here to here in t times, and the remaining time is t, sorry, 1 minus t. The remaining time is 1 minus t. At this point you have reached into time unit 1, and at this point your time is 0. Okay, so just consider you have taken t unit of time from initial point to x point to reach initial point to x point. The remaining time you will take 1 minus t, because the end time is 1. Okay, if we talk about the moment into x axis, okay, this is x2 minus x1, this is x2 minus x1. So you are traveling from initial point to end point, and initially your time is 0, and at the end your time you take is 1. Just consider it's a r, 1 hour. Okay, you take this travel time you take you took 1 hour. Okay, so at this particular point you just consider you took at t times, and the remaining distance you will travel in 1 minus t r. Okay, so if your speed is constant, if you remember the formula of speed, speed equals to distance minus time. So d, this distance is x minus x1.
हेलो सर
Yes, please. कोमल बोलो.
सर आपकी वॉइस नहीं आ रही है
वॉइस नहीं आ रही? बिल्कुल नहीं आ रही, या स्लो आ रही? हेलो. Okay, now it is audible. If it is audible you can write in chat, or you can even speak if it is audible. No? 1 minute, let me check my audio. Now is it audible? Now all right? Is it audible?
Yes, sir.
Okay, okay, okay. So, so should I repeat what I explained? Okay, so at this point, your travel time is you start from traveling at this point. Initial point is time is 0, and if you took 1 hour to reach to your end point, and there is one intermediate point, we have taken x y to find this parametric equation of line. Okay, so at this point you took your speed is constant, and if you remember the equation of sorry the formula of speed is d by t, and that what the distance you travel at x-axis is x minus x1, and time you took the time t. Okay, and here you traveled x2 minus x1, and you took the time 1 minus t. So simplify this equation, x minus x1 into 1 into 1 minus t, x2 minus x1 into t. Just simplify, x minus xt minus x1 plus x1t. Here x2t minus x1t. X plus xt minus x1 plus x1t, x2t. Okay, so now this x2 x1, okay, x, where is it? One more x term is here, x, yeah, x2 minus x, 1 minute, it's x2 minus x1, it's x2 minus x, is it x? Okay, because this distance is x2 minus x, not x1. Okay, so x2 minus x, x2 minus x, and this is okay. So this term and this term is cancel out. Okay, so x equals to, you can write, just transfer this term here, x1 is plus x1, and here this t you take common, and here x2 minus this x1. Okay, so from this you can derive this equation, parametric equation of line, x equals to x1 plus t is the time, and x2 minus x1. Is it clear? Is it clear? If I am audible, please speak. Okay, Vichal, thank you. So in the same way, you can find for the for the y as well, y equals to y1 plus t into y2 minus y1. Okay, how we can find the y, and in this direction, in the y axis. Hello. For the same, you can calculate at the y axis. Okay, here it is, this is your y2, this is y1, and this is time t. Okay, so you can, the same way you can find this equation in terms of y as well, and the value of t always between 0 and 1. Okay, the value of t always between 0 and 1. At the 0 you are at the initial point, and at the 1 time unit 1 you are at the last point or end point of your line. Is it clear? Am I clear? Okay, okay. So in this way you can find the parametric equation of line. Okay, so if you remember, or as just I discussed, the throw condition, point clipping condition, just I discussed. What are the point clipping condition? First, your value of x should be greater than equals to your window xw min. First, you check your value of x should be greater than the left side window. Okay, and the second condition, your value of x should be, sorry, it is greater than x should be greater than the value of left boundary, and x should be less than your xw max, means right side boundary. Means the value of x should be between xw min and xw max. In the same way, your value of y should be greater than to the bottom boundary. Okay, and the value of y should be less than to yw max, means the top boundary. Means always your value of x and y between left left and right corresponding to x-axis, and in between top and bottom at the y-axis. So these are the four inequalities condition satisfied if your line or point is inside to clip window. Now I think I'm clear. Okay. So what are the equation of x, value of x and y? We have derived from this parametric equation. X, if this value you can say is the left boundary. Left boundary, this left boundary, x w means shows the left boundary of your clip window. Let me draw here. This x w min shows the left boundary of your clip window, and x w max shows the right boundary of your clip window, and y w main shows the bottom boundary of your window, and y w max shows the top boundary of your clip window. So the left boundary means x w min should be less than equals to x. What is the value of x? You have derived from this parametric equation, x equals to x1 plus t into x2 minus x1. So it will be x1 plus t into x2 minus x1. You can write delta x. x2 minus x1 you can write as delta x, and y2 minus y1 you can write delta y. So I'm just writing this. It's a left for the equation for the left boundary. The same way for the right boundary. X w max. Okay, x w x should be greater, and x1 plus t into delta x. Okay, the value of x I just put direct from the parametric equation. For the bottom boundary, y w min, from where is the value of y, which is y1 plus t into delta y. Y equals to y1 plus t into delta y for the right, top boundary. Y w max will be greater than y1 plus t into delta y. At this point, if you have any doubt, you can ask. I just put the value of x and y into these four equalities condition to check the point is inside or outside. If you have any doubt, you can ask. Okay, if you have no doubt, I am just extending these four conditions to check your point is inside or outside. These are the four boundaries. So can we write these four equation into a common form? Can we write these four equation into a common form? These above four equation can be write in common form, or can be expressed as in this common form t into some pk less than equals to this qk. I want to change all these four condition into this form where k the value of k maybe could be 1 2 3 4. I'm just giving 1 for the left boundary, 2 for the right boundary, 3 for the bottom boundary, and 4 for the top boundary. These are the four boundaries. This value of k is represent the these four boundaries. 1 is for left, 2 is for right, 3 for the bottom, and 4 for the top. So let's change these four equation into this common form. First, for the left, this is the equation for the left. Okay. So for the t term, just transform this term t terms into left side, and these remaining terms should be in the right side for getting this form of equation. Okay. So transform this term minus t delta x less than equals to x1, transform this term into right side, x minus xw min. Okay. Okay, so this is the equation form. In this form, this equation we have transformed into this form. Now for the right side, right boundary, for the right boundary, this term should be in left side. So minus t delta x, and here it is greater than equals to. Okay, so greater than equals to x1 minus w xw max. Okay, this is the form, but here in our common form there is a less than equals to, but we are getting greater than equals to. So for changing the sign of this, we have to in both the side we have to change this sign, means we have to multiply the minus into both the side. So this term will be minus into minus plus t delta x. This term now it will be less than equals to, and minus x, and minus x1. This term will be plus, so plus xw max. So in this way we have changed this less than equals greater than equals to into less than equals to apply the negative from both the side of equation. Okay, so now this is the common form of we in the common form we want to change. Okay, third, for the bottom boundary. Okay, now bottom boundary, this is the equation. Check transform this term into left side and this term into the other term into right hand side. So it will be t delta y. Check which sign is there, is less than equals to y1 minus yw min. y1 minus yw min. It is in the same form. So now for the top boundary, again transform this t term into left hand side, the other terms are into right hand side. So this is minus t delta y minus t delta y here it is greater than equals to y1 minus yw max. y1 minus yw max. Okay, so again there is the greater than, but we require to less than, so we apply both the side negative sign. So we will get t delta y, 1 minute, it is I think minus. Okay, t delta y less than yw max minus y1. Okay, it is 1 minute. We have this, in this there is a minus t delta y, we have not written minus, so it is minus. Okay, so these are the four equation in this common form. These are the four equation which we want to get in common form. Okay, okay, so now write the value of this pk and qk from these four equation. Value of pk and qk. The pk, p and q are qualified as. Now write the value of p1. P1 means equation 1. You get this is the first equation, and your p, this p in p, t is the common term, the remaining term is minus delta x is your p1. P1 is delta x minus. Okay, and p2 is, just first while write the q1 as well. Q1 is the remaining term, which is the remaining term is the x1 minus xw min. x1 minus xw min, and p2 equals to sorry, this delta x, and q2 equals to the remaining term, right hand side remaining term, which is xw max minus xw1. Okay, on p3, which is minus delta y, and q3, which is y1 minus yw min, and p4 is to plus delta y, and Q4, which is YW max minus Y1. So we have find all the values of P1, P2, P3, P4, and Q1, Q2, Q3, P4. P1 is for the left boundary, P2 for the right boundary, P3 for the bottom boundary, and P4 for the top boundary. Okay. So again, I'm asking, if you have any doubt till this point, you can ask. If you have any doubt till this point, you can ask. So I'm ending this meeting, and please rejoin this same meeting. Okay, because the time is over. The 50 minutes is for, which is scheduled for this meeting has been over. So I'm just ending this meeting. So please join again the same meeting. Okay, is it clear? Am I audible? Okay, so I'm ending meeting right now. Please join the same meeting.